Today we're going to talk about water, what makes a waterway healthy, and how river otters are great ambassadors for keeping our waterways healthy and for all beings. So, as I said, I'm Megan Isadore, River Otter Ecology Project co-founder and director, and my slides are not wanting to go. There we go. We are grateful to live and work on the unceded lands of the coast and the Bay Miwok, the Ohlone, Wapo, and Pomo tribes. We endeavor to respect and follow their soul-deep connection to the life of the land. This land and water, this place, this is where we center our families, communities, our work, and our play. And it's where we start making a difference because we know that protection begins with us. Each of us doing something to help our planet can send ripples into the future. River Otter Ecology Project creates lasting protections for local waterways using community science, which we're going to talk a lot about today, research, education, and advocacy. Our ambassador is the North American river otter, an indicator of healthier waters. You'll hear more about that later in the program, but first I'm delighted to introduce my colleague and member of our Science Advisory Board, Heidi Island. Dr. Island is professor of comparative animal behavior and neuroscience at Pacific University. Heidi is a strong and creative conservationist, a lavender farmer, a talented artist, and she cares for a great many animals at her home. All of this in addition to her busy research and teaching life. We're honored to have her lend us her talents and her skills. Welcome, Heidi.
Thank you. Before we get going, thank you all very much for being here, and thank you, Megan and Terrence, for allowing me to join you tonight. This is my website. I have a screenshot of it just so that you know while I'm giving sort of my portion of the Waters for Otters, while Megan's going to do the Otters for Waters portion. Um, all of the references that I make are on this webpage under the conversation and web event. I also, you'll notice in all of my photos, I give the distance, the lens that I'm using, as well as the type of camera that I'm using. This adheres to the Canadian Geographic wildlife photography ethics. There are a lot of organizations that have wildlife photography ethics, and I adhere to those when I give presentations. I also adhere to Share Savvy. If these are two organizations you haven't heard of, Share Savvy is about responsible sharing of media through social media, through Facebook and TikTok and Instagram, things that you see a lot relative to wildlife and you don't necessarily know province and you don't know whether or not they're from a reputable institution, whether it's an AZA zoo. And so Share Savvy has an outline for that and for posting and sharing and advocating. So all of that is on my website, as well as links to articles that I cite in the talk. So again, thank you for coming tonight. I'm an animal behaviorist initially. I was interested in studying animal welfare, specifically with rehabilitated and orphaned animals in zoos and aquariums. I was interested in species that were wild caught, orphaned, and needed rehabilitation. Zoos and aquariums at one point started really focusing on conservation, rehabilitation, and outreach. And it was through that that I thought they needed some support. Research is often not something that they have budgets for. And so I started aligning my research to help support zoos and aquariums that were doing conservation and rehabilitation work. After about 10 years of doing that, I got itchy to get in the field. So around 2018, I started studying river otters in the field on Whidbey Island in the Salish Sea. And I was interested in doing comparative studies of wellness of wild river otters to river otters in captive environments. My research was with river otters and sea otters. And so one of the things that I discovered as soon as I started doing the field work with otters is you cannot study otters without, and certainly not otter wellness and health, without also becoming a water conservationist, without also becoming someone who pursued um, understanding healthy waterways and healthy water ecosystems. So, depending on where you are in the world, otters are sometimes called water dogs, or river wolves, or sea cats, or water snakes. And this really illustrates their relationship and reliance and the criticalness of water for otters. Among the 14 species of otters, one is entirely marine, the sea otter. It's the smallest of the marine mammals. It spends about 90% of its time in inland bays and is uniquely adapted to marine environments. The remaining 13 otter species are semi-aquatic. Studies using time depth recorders have measured their activity budgets at about 28 to 40% of their time in water. And this isn't just freshwater, there are marine foraging river otters as well. And their time in the water is really dependent upon their sex, their maturity. If it's a female and she has cubs, kits, or pups, depending on what species you're talking about, the way that we reference the pups is different. Also, depending on where you are in the world. And you'd think that this would be great. You know, they're semi-aquatic mammals, and 71% of the Earth's surface is water. This shouldn't be a big deal, but only 2.5% of that water is freshwater. And most of that is tied into ice caps, into glaciers, into snowfields, with less than 1% of the total fresh water reflected in available water for consumption or living that goes to rivers, lakes, and groundwater. This is changing with climate change, but that's still not a lot. And what that means is that as that water melts and it becomes part of the watershed, what makes a watershed is essentially the effluvia that comes from those frozen trapped sources. And then it moves through the ecosystem in lakes, tributaries, riparian zones, and into eventually the ocean. All species require water, but for those that are semi-aquatic, like the river otters, or wholly marine, like the sea otters, healthy watersheds are what matter. And part of what makes a healthy watershed, the area of land where all the water drains into a common body, like a river, lake, or ocean, the unique biochemistry and physics of water are part of what make a watershed healthy or sick. So Terrence, you can go ahead and forward the slide for me. So some of these unique properties are in its molecular structure and its polarity. So water is a universal solvent. This means that their unique molecular structure and polarity allows water to dissolve ionic compounds. Those are atoms that carry a charge. Salt, sodium chloride, for example, is a molecule that carries a charge. Um, easily dissolving in water also are polar molecules like carbohydrates or sugar. But what doesn't dissolve in water are nonpolar molecules or oil. So this is like dissolves like, and the ocean is the largest dissolver of carbon dioxide. It is the largest carbon sink on the planet. We tend to think of the rainforest as the lungs of the planet, but the reality is that 25 to 30% of the atmospheric carbon dioxide is absorbed and dissolved in the ocean. And so this is another really important part. It is a purifier for our environment. In addition, it is a regulator of temperature. So the density of water is unique. As a liquid, it's actually denser than as a solid. And so when the temperature decreases and becomes more dramatically cold, the frozen surface area of water actually floats to the surface and insulates the underlayer of water. That helps maintain a more modest temperature in extreme climates that allows fish and invertebrates to continue to function in those extreme colder temperatures. In addition to this, with the density difference, that density allows for greater transmission of sound. Sound is essentially through compression of pressure, and those sound waves travel further in water than they do in air. And not only do they travel further, the energy remains longer. And this is really useful in communication for some animals that communicate in the water. Cetaceans come to mind. They're able to communicate and their song can be heard across the ocean. We don't tend to think of this as much as being important and relevant for freshwater ecosystems, but bear in mind that our anadromous fish, our salmon and trout that travel from saltwater to freshwater to spawn, they actually use sound as part of their migratory signaling as well as communication. And so when we have noise, which is a kind of pollutant, and it's something that actually makes water healthy or sick. So just like you might think of pollution or effluviant, runoff that enters into the water, changes in temperature that can affect dissolved oxygen, sound conduction, and thereby noise, where we meet a threshold that is beyond the ambient sound that's native to a particular ecosystem, that can also make water sick. And so it's not something that we typically think about. But then if you imagine some of the mass mortality events that have happened as recently as 2 weeks ago, where you find cetaceans washing up on beaches, some of that is thought to be in part the result of ship vessel noise. It can be the result of drilling. It can be the result of any number of things. Vessel traffic in general is a really big one. And so that too contributes not just to the marine ecosystem, but to freshwater ecosystems as well. Mining, for example, can create both heavy metals as well as noise in the environment. So if you'll proceed forward for me again, Terrence. So what is healthy water? This is part of the watershed of Whidbey Island. Whidbey has 4 main lakes that are part of the hydrology of the island, as well as over 300 bodies of water. This is one of those smaller bodies of water. It's a very small residential lake, but it does renew. It has freshwater seep for our seepage from Crockett Lake, which is just there in the distance. It's not very deep. It's about 20 feet. But it does have fresh water that comes into the system. And if you look at this, it appears very, very clean. And so these are 2 things that we often think of when we consider what is healthy water. Is it renewable? Is it clean? And so with Whidbey, we have all of this fresh water. Our watershed is also surrounded by the Salish Sea. If you'll proceed forward, Terrence. It is a 37-mile island from north to south. The narrowest part is about 1.5 miles, with the widest part at 10 miles. And so there is a lot that can potentially contaminate the watershed. What we found is that the river otters on this particular island are doing really well. Their density and numbers are doing quite well. But we are paying attention to the ways in which they're affected by their watershed. We have 2 naval areas, one big naval base and an outlanding field in Coopville and one in Oak Harbor. They are associated or have been associated with brominated flame retardants in the watershed. And so we're paying attention to some of those solvents. Also, the jet noise on the island can be quite a lot. So we have 2 things that are contributing to ways in which we need to be extra careful in monitoring what's going on with healthy water in the area. If you want to proceed. So this is that same lake. This is Admiral's Lake. So we have a renewable watershed, or we have a renewable water. We have seepage. It appears clean, and it's supporting life. And so if you'll animate the slides for me, or thank you. So it's renewable. Next one, it's clean and pure. And so the next question becomes, is it life-sustaining? And we have otters here. There are 2 romps. This is the tide gate. It is part of what allows for extra fresh water to be released into the bay, Admiralty Bay. And it actually, if you were to extend this picture all the way to you're facing the left, it goes over a small residential street and directly to the bay. And this culvert, the tide gate, and the culvert beneath the tide gate is used by the otters. And the three on top are a kin group, and the three around the base of this tide gate are bachelors, one of which is probably the pup to the female. The maternal member of the group, she's the one that's facing us. Um, and I don't know who the other two males are. They're a small juvenile bachelor. And this is not uncommon on Whidbey to see multiple romps overlapping and socializing. This is a latrine site. So this is where they come, they do their otter dance in evacuating, marking this space, but they're not guarding it. They're not particularly territorial. So we have this thriving community of river otters. You can go ahead and proceed to the next slide. We have a renewable source. It appears clean. One of these, this is like a Sesame Street. I apologize if this is too pedestrian. But one of these images is obviously not like the other. And one of these is also a different water source. So A is Green Bank Pond. And B is Admiral's Lake again. Both of these are supporting some algal growth. But in looking at this, which one appears safe for swimming? I'll do a quick look in chat and see what people think. A or B, where would you rather swim? Green Bank Pond is A, B is Admiral's Lake. B, lots of B's. Okay, great. So if you'll proceed to the next slide again. So A is the one that's safe for swimming. And one more click. This is Green Bank Pond. This is the challenge of looking at water on face value. It appears dirty. It has all of this filamentous algae. It's also referred to as planktonic algae or green water algae. And it looks gross, but it's not. In smaller volume or when it's less abundant, it's actually beneficial for small amounts in a pond ecosystem. And this otter is a little juvenile male that for 2 years would come during tadpoling in the early spring and would have the entire pond to himself. You could stand up in this pond. So I actually got waders because I was curious and wandered in there. It goes about to my chest. It's nasty. There's lots of duck and goose waste in there. And if you have a really good arm, you could throw a rock and hit the other side of the pond at any given spot. It does not appear to be a place that would be tremendous, but this is not harmful algae. If you'll proceed to the next slide, Terrence, there should be 2 images. So what you're seeing there is the same lake, but the algae that you saw in B that you preferred to swim in was actually the start of a cyanobacterial bloom. And this happens every summer, late summer, early fall. It's the result of warming temperatures. As I said, this lake is not very deep. It's about 20 feet. And the cyanobacteria happen fairly regularly. And this is a photosynthesizing bacteria that is toxic. It eventually corrects itself. The community has elected not to use invasive means of getting rid of it because that in and of itself can sometimes be as bad as the cyanobacteria, which is seasonal and it doesn't last for very long. The otters do still use this lake when the cyanobacteria blooms are in place, but the blooms tend to stay along the bulrushes. And so the center of the lake is not quite as bad, but they don't go where you see the cyanobacteria along the margins. So they don't use the tide gate during that time. So this is a challenge. It appears as though the water is clean and healthy, but the one that is the most unhealthy looking is the one that's actually safe, and the one that appears great is the one that isn't. You can go ahead and proceed forward. So we've said that healthy water is potentially renewable. It's clean. One click, please. It's also life sustaining, but we don't know necessarily what life sustaining means. This is very dynamic. Um, and so, how do we measure what that is? And if you'll move to the next slide. One way we can measure, I'm sorry, go ahead and go back. One way we can measure life supporting water is through the definition in the EPA. So the Federal Water Protection Control Act of 1948 later became the Clean Water Act of 1972. And this was one way legislatively that they defined what a clean or healthy watershed was. And it is to protect and maintain the chemical, physical, and biological integrity. Integrity is defined as natural structure and function of ecosystems for our nation's waters. And then this was the objective set about as intended by Congress. You can tell that this is really hard to measure. If you are a scientist and you're trying to figure out if a water system is healthy, going by this is not particularly useful. It's not operationalized. It's more like a vision statement. So if you'll proceed to the next slide. So what is life supporting water? Life supporting water is water in balance. It has a harmony of available dissolved oxygen. That is, the dissolved oxygen that's available is enough. You don't have a eutrophic environment. Your nutrient availability with nitrogen, phosphorus, and potassium is not too much. And you'll notice these are the same numbers that you find on standard organic fertilizer. Your NPK numbers are what you use to supplement your garden. And what's interesting is river otters are a great support of marine derived nitrogen. So they actually can help support a water based system through their marine derived waste if they're a marine foraging river otter. The third is a suitable temperature, and this varies widely depending on what body of water you're looking at, whether it's freshwater or saltwater, if the saltwater is tropical, or if it is um, uh, along the Pacific Northwest, or if it's Arctic. So, suitable temperature varies by body of water. The fourth is a suitable pH. This too varies, but not as much. So, if you recall from chemistry in high school, our biologically neutral pH is 7. This is what our body pH typically is. The ocean is slightly alkaline at about 8 to 8 and 8.4. Freshwater is anywhere from 6.5 to 8.5. So you need a suitable pH. Without a suitable pH, you can have ocean acidification, which is terrible for coral reefs. It makes all kinds of invertebrates vulnerable. The calcium bicarbonate that make up coral reefs begin to degrade. The zooxanthellae that live within the polyps of the coral reefs die. So both temperature and pH are really important for life supporting water. And then we want absence of harmful pollutants. And those harmful pollutants aren't just liquids and solids, they can also be sound, as I mentioned before. Some examples of harmful pollutants, it's a long list. You can proceed forward with the next slide. Include excess nutrients like our fertilizers, our cleaning products, sewage, um, are per and polyfluoroalkyl substances. These include perfluorooctanoic acid as well as perfluorooctane sulfonate. We think of these as PFOA and PFOS. These are two specific examples that are part of the PFAS umbrella chemicals. These are called forever chemicals because they are synthetic man-made chemicals that are frequently used in non-stick products, that are used in stain-resistant products, and they persist in the environment. And they also persist in us. So if you are exposed to PFAS, those chemicals actually dock in adipose tissue. And they dock in adipose tissue for our marine mammals in particular. You hear about PFAS a good deal when we're talking about the southern resident orcas in the Salish Sea who are struggling to get enough food. Their preferred forage is Chinook salmon. It is on the endangered species list. And so they're not getting enough. And what happens is when they start to lose weight, all of the additive, the summative consumption of and exposure to PFAS that is docked benign in adipose tissue, when they begin to lose weight or they catabolize that fat, it releases those chemicals into the bloodstream and you get a heavy dose, and it's really hard on the liver. It can result in hepatic dysfunction or hepatic failure. Heavy metals too from mining. This is mercury and lead, arsenic and cadmium. Um, Pesticides and herbicides, pharmaceuticals and health and beauty products, in particular sunscreen is one that we really are attentive to. If you can buy reef safe sunscreen. Pharmaceuticals includes all kinds of things. Bear in mind, when we treat our wastewater, often those chemicals that are in our urine, whether they're for our veterinary medicines, 51% of veterinary medicines were originally for human use, and humans use them. So not just us, but our animals also have pharmaceuticals that end up in our watershed. Stephanie Norman out of the Salish Sea and a co-author, Joe Gatos, both veterinarians, one through CDOC Society, and I think the other is through UC Davis, but not the CDOC. They were looking at antibiotic resistance in the Salish Sea among marine mammal carcasses. They looked specifically at dolphins and harbor seals and found that 38% of the carcasses had at least one antibiotic and antibacterial resistant component. So they were resistant to at least one bacteria. Micro and nanoplastic, the biggest contributors to micro and nanoplastics are tires, clothing, and packaging. Clothing because of synthetic fabrics. So not your cottons or your wools or your linens, which is cotton, but your synthetic clothing like nylon, propylenes. And then petroleum and hydrocarbons. These are what I grew up worrying about. The hydrocarbons or hydrofluorocarbons, the stuff that was in aerosols was one of the things that we were really attentive to. Now also we're looking at the fluorine with that for our PFAS. Chlorine and chloramines, these are used in water treatment facilities. And then of course, dissolved solids. Those are road de-icing salts, water softener discharge, and so on. So these are the biggest contaminants for the watershed that upset the balance. And you can proceed forward, Terrence. I don't know if I can proceed forward. So if we look at the Watershed Health Index, this comes from the EPA. So the same Clean Water Act legislation provides sort of a means of assessing the health of a watershed. You can look at landscape condition, which we did and wasn't very successful. I too would have picked B. The habitat, another way of looking at whether or not it's clean or healthy versus sick. The hydrology, is it flowing? Is it stagnant? The geomorphology, does it appear as though there's a lot of emergent rocks or other things that might help and contribute to cleaning or providing eddies or moving water? Water quality, this is just testing through water testing materials. And then biological condition. This is where utilizing animals as a means of assessing watershed health can be really helpful, and where both Megan and I spend most of our time. And so if we look at biological condition, and you can proceed forward to the next slide, we can measure that through ecological sentinel species. So keystone species, bioindicator species. You'll hear also people refer to flagship species or charismatic species or umbrella species. Keystone species or keystone predators are the ones that you hear or what you hear about usually the most. They have a disproportionately large impact on its ecosystem relative to its abundance. And this term came to us in the 1960s. You can proceed to the next slide by Robert Payne. Robert Payne, in 1963, was a new professor at the University of Washington, was interested in nearshore ecology, and particularly interested in the competitive, competing species between purple sea stars, Pisaster sea stars, and mussels. They occupied the same space. Purple sea stars are a predator also of mussels. So not only do they compete for the rocky shoreline, but also the sea stars forage on the mussels. And at the time, everyone thought in ecology that the banded nature of and segregation of different species along the intertidal zone was based on where the ecology was most conducive for those species, not considering the relationships between those different species. And from this work, he developed the term called trophic cascade. You might think of it as the the food web. But trophic cascade also came from Robert Payne. This paper, this is a screenshot of his original paper, and it is scented. This is a scented paper. It vibrates with the power of how important this paper was in the 1960s. It changed the whole landscape of ecology. And what he found in 1963 did essentially 3-year study along Macao Bay, and he had 2 different areas of the rocky shoreline, and removed sea stars in one of the rocky shoreline areas and left it in the other. One was just for monitoring, one was removal. And in the removal, you can see he's removed all of the Pisaster ochraceus, which is the Latin name for the sea stars, purple sea stars. He removed all of them and then observed to see what happened relative to the mussels. And the mussels took over. They had no predator. It was unchecked. So it was Disneyland for mussels. Not only did they occupy all of the rocky shoreline that once included the sea stars, but they expanded further down to the shore. And so they pushed out also all the algae. And so then we ended up with a monoculture of mussels. Nothing was keeping them in check. And so what he determined from this, and a later paper in 1969, he came up with the term keystone species, where if you think of architecture, there's one keystone that everything else is supported by. If you think of archways, for example, the keystone species is kind of that trapezoidal stone that holds the arch in place. The purple sea stars were this keystone species. If you removed them, because they had such a disproportionately large impact on the environment, the whole system collapsed. Not only did the sea stars go away and the mussels took over and created a monoculture, but everything else that was living off the mussels, that were living off, that were also eating the sea stars, that were also eating the algae, they all collapsed. Next slide, please. Less than a decade later, Jim Estes, the late great Jim Estes, just passed away this year. So this is a nod to him as well. He applied this model less than a decade later in the Aleutian Islands. He was looking at 2 Western Aleutian Islands, and it was kind of a natural experiment. He didn't do anything but observe and and was on top of the literature. He had read Payne's work and said, you know, I'm seeing this exact same thing in Alaska, but I'm seeing it relative to kelp forests. And so what's happening is one area called Near Island has no sea otters and it's a urchin barren. So the kelp had been overgrazed, and because there were no sea otters there to keep the urchins in check, the urchins took over. There was no kelp, and it was just a desert monoculture of urchins, which are a highly voracious predator, or excuse me, not predator, grazer. And so you ended up with the sea otter, or excuse me, the sea urchin barren here in the area where there was no sea otters. And in the area where there was, called Rat Island, they had this gorgeous, diverse ecosystem. And so the sea otters, like the Pisaster ochraceus, were a fundamental keystone species in helping to maintain the ecosystem. River otters, you can proceed to the next slide, are similar. They are also a kind of sentinel species, not a keystone species. We call them an indicator species. So they are not rearranging or adjusting the architecture of the environment, but they serve as a canary in the coal mine. We call them a bioindicator or an indicator species. One click, please. You'll notice on this river otter, this is in Coupeville at the Coupeville Pier. Um, this is a tumor. This particular tumor is one that you see also in Asian small-clawed otters. It's a squamish cell carcinoma. It's not uncommon in North American river otters. Sometimes they're called a pleural tumor. Um, in Asian small-clawed otters, you'll see them on the tongue. Does this mean that the watershed is heavily polluted and unhealthy? No, it only really serves as an indicator if you're seeing this a lot, if you're seeing all of the river otters suddenly having these tumors. It could be any number of things. Some of the things that contribute to tumor development is old age, um, uh, stress, and then, of course, the pollutants as well. So this is essentially one way in which river otters help us identify whether or not an ecosystem is healthy or not. And I will turn that over to Megan.
Thank you so much, Heidi. That was a wonderful presentation and so interesting. And I hope it's going to help us all learn a little bit more about water and how important it is to us, important it is to river otters and everyone else, every other species in the environment. So we just went through a bunch of reasons why river otters are a good indicator species, and I'm going to give you 1 minute to put what you learned into the chat. This isn't a test. I just have a little survey to let us know what you think make river otters a good indicator species. There are no wrong answers to this. And I have to try to turn, I'm just going to give you a minute because we don't have a lot of time left.
Sorry, I went over a couple minutes.
Oh, that's fine. It was fascinating. Indicate water health? Yes, they can be indicators of water health. And Christine, I love the term keystone as well. Thank goodness for Dr. Payne. Ah, Joel, a man after our own hearts. They do embody the nexus of biological, chemical, and physical water quality. Thank you for that. Help indicate water health, availability of good food sources. Yep, all of this is great. So water quality sensitivity, we talked about bioaccumulation, habitat requirements, trophic position, mobility and range, and one of my favorite things is the historic decline and recovery of river otters. River otters were missing from large parts of the United States because of trapping, habitat change, and pollution for many years. And they're starting to recover. River otters are showing us that things that we can do, that things that we do can send ripples of goodness into the future as well as ripples of badness. So river otters started returning to our waterways since we started addressing those pollution trapping and habitat loss problems. And the Environmental Protection Agency begun in 1970. Passage of the Clean Air and Clean Water Acts shortly thereafter were really helping. This new era in conservation allowed us to make substantial gains in protecting biodiversity. We haven't gone far enough, and in fact, we are now going backwards, which is extraordinary bad form on everyone's part. However, we are conservationists and we're used to setbacks, we're used to roadblocks and resistance, we're used to fighting the same battles over and over, and we are not stopping. Instead, River Otter Ecology Project is expanding our reach from California across the nation to help water protective and other conservation organizations use river otters as an ambassador and a bellwether species. So why river otters? We just talked about them as indicators of watershed health, but also how does that connect to protections for our waterways? And it begins with people, always. Humans tend to worry about ourselves first and about other species to varying degrees. To work on protecting biodiversity, we seek that gut level connection between people and a charismatic otter, river otter, um, because that is what allows people to move forward. Otters connect people and science, public engagement, and policy. And I'll tell you more about that in a second. But first, how can you not be in love with these little water sausages, as so many people call them? How can you not see them and think, I have to save them? I have to save this watershed. I have to save their habitat. I have to protect them. That's why river otters are such a great conservation ambassador. And very importantly, otters help connect people with science, with public engagement and policy. You know, science is terribly under attack in the United States right now. And river otter presence helps people to become interested in science, interested in water, interested in the connections that are made among wildlife, humans, and policies. I like to call river otters the gateway drug to advocacy. As community scientists, we really don't need to be experts to act. We need some guidance and we need a conduit for action. And speaking of conduits, this really bad looking waterway is actually a very thriving area for river otters because it has plenty of healthy fish for them to eat. It has habitat, although it's not habitat we would consider good. It looks just like some people look at that and say, ugh, horrible, degraded habitat. But otters are really good at using what people build to, as these otters were using this pipe to cache their food in, to stash their babies in, to hide in, to rest in, to nap in. So wildlife in general has different levels of ability to adapt to human mediation of the landscape. And these guys just happen to be really good at it. So I'm going to go on to talk about how we are using our community science otter spotter project to support conservation on a larger scale. In We started our project in 2012, and at that time, the pink area of the map, this is California, specifically Northern California. Here's San Francisco Bay down here. The pink area was considered river otter range. We started gathering community science sightings of river otters, and we did that for about 5 years. And then we submitted our data sets to California Department of Fish and Wildlife. And at that point, they enlarged the river otter range because clearly they had spread out all over the state. Now, this is really good information. It's telling us that if river otters are indeed an indicator species, we are doing something right. River otters are spreading around out. They seem to be thriving in different ranges where they haven't been seen in many decades. But who else uses this information? And many people, advocates for wildlife corridors and better development decisions. We use these maps for this. Restoration managers for better outcomes. A lot of restoration projects are geared toward endangered species, and we can't ever forget that river otters are a voracious predator. Wildlife habitat managers are very interested in all of the wildlife that's in their ranges, so state, local, and county parks, national parks, wildlands, of course, transportation authorities, highway crossings, especially in California, highway crossings are becoming a very popular thing to do. And thank goodness for that, because almost every dead otter that is reported to our portal is hit by car. Otters are small, they run around quickly, they travel a lot at night, and people don't see them, they hit them all the time. So toxic spill response teams, we don't think of that all that often, but we have oil spills, we have toxic spills through our railway systems, through our shipping lanes. The people who plan for those and who remediate them need to know what species are in their area. Wildlife rehabbers, obviously. Teachers use our data sets all the time, and we've used them extensively to help train teachers to be good environmental educators. Researchers, we share our information with researchers at will. So, Otters for Waters, what is that? Our project worked so well that we decided that we would scale our impact nationally. And I'll just give you one example of impact. Highway 37 is a busy four-lane commuter highway crossing part of San Francisco Bay, and it crosses between the bay and the wetlands. Wildlife is hit by cars there regularly, all kinds of wildlife. One of our community science otter spotters commutes daily on the highway, and she started documenting the dead otters using our Otter Spotter portal. And once we realized it was a hotspot, it allowed ROEP, River Otter Ecology Project, to get in touch with Caltrans, our transportation agency. We went out to the site with their biologist, and together we came up with a plan both to improve the existing culvert under the highway that the otters weren't really able to use anymore, but also to add fencing to funnel wildlife away from the road and toward the culvert. Now, this is a win for the wildlife for sure, but it's also a win for community. People who care enough to notice what's going on in your own backyards and report it to us make a noticeable and concrete difference. We actually use the information you give us. And it's really important to us to tell that story so that people understand that when they're reporting otters or reporting any kind of wildlife to us, that information gets used. Some other examples of this are cattle straying into a delicate and protected wetland, a restoration project that left exposed asbestos pipes with leaching into a tidal wetland, fishing line left on banks, and so on. These are all things that we can ameliorate if we know about them. So otter spotters serve as observers and reporters. You are our eyes on the watershed. Local people noticing what's going on where they live and reporting it. So we decided that this was working so well for us in California that we would start Otters for Waters. And what it is a community-centered conservation advancing local watershed goals. Otters are the charismatic drivers of public engagement, and our focus is on partnerships. We don't know what the local conservation goals should be, but the people on the ground sure do. And we've decided that we would use our experience. Let's move on. We would collect otter sightings with our partners via Otter Spotter, build community awareness and stewardship using our experience as a guide, and thereby support local action across the country for conservation, restoration, resource management, and policy changes. Now, I'm hurrying through this because I want to save a little time for questions. Some photos of the children who love otters, of course, who doesn't love otters. Education and teaching children young is the way to go for conservation. Early impacts for our Otter Spotter program. Arizona, one of our, oh, maybe our first project, has had observations. We've done a podcast, radio and print media. We went out there last spring and led a walk and a talk, which were very delightful. And there's a partnership going on with them. And this is to us, organizations who are taking the information that we have and using it in the ways that work for them is the most important thing. That is success. the Elizabeth River Project in Virginia. Both of those pictures are from there. We went out there and launched the project a couple of years ago, and they've had lots of observations in the Elizabeth River in Norfolk. We did an in-person launch, radio, print, new partnerships. Again, new partnerships forming around otters. Elizabeth River Project is partnering now with Virginia Aquarium and the Virginia Zoo. The whole idea, our vision, is connected as organizations connecting to support waterways. And let's not forget, this is what we mostly see um, when we're taking people out, when we're talking about otters. It's fun. What's the common denominator in these photos? It's fun, energy, people feeling welcome, people feeling like they're able to do something to support nature. And when you're looking at otters or looking for otters, you can't help grinning, smiling, and having a great time. So, what's next for us? As you can imagine, this is a very big lift for a three-person organization. We have three staff members. We have a fabulous board and volunteers who support us all the time. We would like to have next year a partner meeting. We're going to share experience with our partners, strategize, learn from each other, and teach each other what's working, what do we need to do differently, how can we invite new partners. And in time, we will have a web of water protectors based on river otter charm across the country. So we're attracting new partners. As we do that, we need to ensure continuity of attention to local goals. I think that's the main thing that we need to do. We need to understand what our partners need and want, and we're working very hard on that now. We're doing fundraising, of course, which becomes ever more difficult. Federal funds are probably not in the cards for us. Corporate grants, donations, and contracts are the way that we are supporting our project right now and probably far into the future. So we're asking for your help. We are just a little under $500 away from our fundraising goal for our first Otters for Waters partner meeting, which we're having next year. And our organization doesn't have time to mess around. Our waters need us. We need to be able to tell our story. We need to get the word out. We need to get those otters supporting waters. And we are asking you to support our fundraiser if you can. Our goal was $5,000. We're only $500 behind, and today is the last day. So I'm hoping you all can help us out. And Terrence will put the link into the chat. Before we take questions, I want to shamelessly plug Heidi Island's book, which is coming out next spring on World Otter Day. It's a journey through the natural history of otters and why they matter, called, of course, Romp. I've been lucky enough to read a couple of chapters of it, and it's great. I think it's a must read for all of us. And I hope we can have Heidi come back and talk to us about the book after we've all bought it, read it, and have a great discussion about it.